So we now proceed to modeling of the first system na i-model natin for this course, which is electrical networks. Okay, so yung electrical networks natin nahati sa dalawa, yung passive networks at active networks. When you say passive networks, these networks are composed entirely of capacitors, resistors, and inductors. While yung active networks naman, ito yung meron ng operational amplifiers sa circuit niya. Okay. So, basically, table 2.3 would summarizes yung um, mga relationships between quantities sa mga components in a passive network. So, meron tayo ditong voltage current relationship, okay, between capacitor, resistor, and inductor. Okay, meron tayong current voltage relationship, okay, and meron tayong voltage charge relationship. Okay. Pero ang titingnan natin dito mabuti is yung impedance niya. Okay. So basically, impedance is yung voltage across the component divided by the current across um, the the component, pero in Laplace transform. Okay, so yun yung tatawagin nating impedance. Okay, so basically nakuha yan dito sa voltage current relationship. Pag ito kinuhanan nyo ng Laplace, pag ito kinuhanan nyo ng Laplace transform, basically this becomes B of S equals I1 over C, okay, times IS over S. Okay, remember yung integration property ng Laplace ninyo. Okay. Itong integral, okay, becomes division by uh, S. Okay. So, ngayon, pag divide natin ngayon yung ds divided by is, lalabas dyan is 1 over cs. Okay. So, makukuha natin ito. Okay. So, basically, ang impedance niyo is a form of transfer function. Okay, wherein ang output natin is voltage at ang input natin ay current. Okay, so yung Ds natin is the transfer function describing that relationship. Okay, so ganoon din sa resistor tsaka sa inductor. Okay. So in this case, kung magko-concentrate lang tayo dito. Okay. And by the way, ito yung mga units niya. Okay, so please take note of those units. So, in that case, ang gagawin natin sa mga circuit natin is lahat ng impedances dito, ita-transform natin sa kanyang Laplace transform equivalent o sa impedances niya in Laplace transform. Okay. So say for example, itong circuit na to, pag i-convert natin ito sa kanyang Laplace transform circuit. Okay, tatawagin natin siyang Laplace transform circuit. Ito, okay, magiging V of S yan. Okay. So, kung natin yung Laplace transform ng V of T sa V of S. So, itong impedance na to becomes LS. Okay. Ito is still R. Okay, ito becomes 1 over CS. Okay. So, ngayon, naka-ano na kayo ngayon? Naka-Laplace transform na yung impedances nyo. Yung current ngayon, magiging I of S na yan. Instead of I of T, magiging I of S na yan. Okay. Then, itong VC of T nyo, magiging VC of S. Yan. So, yan na yung mga quantities niyo. So, we call this now the Laplace transform circuit. Okay, Laplace transform circuit. Okay, so tatawagin natin siyang ganun. Okay. So, yung impedances na yun, nakuha natin dito sa table na to. Okay. And then from there, ayun, i-apply na natin yung either Kirchhoff's law or yung Ohm's law. Okay. So, in this case, if we are to work on example 2.5, and we want to find the transfer function VCS over VS, okay, pwede natin gamitan ito ng KVL, okay, o kaya, since series circuit naman to, pwede natin din gamitan ng voltage divider. Okay, so let us try let us try to use KVL for this particular example. Okay. So in this case, kung i-KVL natin siya, okay. So basically, susundan ko lang tong loop na to. Okay, susundan ko lang yung loop na yan. Okay. So by KVL, you would have V of S, okay, minus LS times I of S, okay, plus R times I of S, okay, plus 1 over CS times I of S equals 0. Now, kapag ka ganito at nagsusulat tayo ng mga ganitong relationship, okay, at alam naman natin na naka-Laplace transform siya, initially, pwede natin i-drop tong of S na to, yung itong independent variable na to. Okay, so itira na lang natin tong function name natin, which is, for example, in this case, V, tapos in this case, I. Okay, kasi ang sinasabi lang naman natin sa V of S at saka I of S is they are a function of S. Kasi alam naman na natin na yun. We shall just, we shall use yung function name na lang nila instead. Okay, so instead na isulat natin siya lahat. So, equivalently, we can rewrite this as V minus LS times I. Okay, plus, minus pala to, sorry, minus tsaka minus. Okay, KVL. So, this is minus R times I. Okay, minus 1 over CS times I equals 0. Okay, so, for ito, pwede natin ilipat itong terms na to na may mga i's, ilipat natin sa kabila, tapos factor out natin yung i. Okay, so that becomes V equals LS plus R plus 1 over CS times I. Okay, so, ayan. Then, what we will do is, we would find now yung equivalent na I. Kasi ang kailangan natin hanapin is basically VC. Okay, kailangan hanapin yung VC of S eh. Okay, so, solve natin yung VC of S galing dito. Okay, so we know for a fact na ang dadaan na current dito sa capacitor niya is yung I. Okay, now by Ohm's law, we can deduce na yung VCS niyo or VC, for simplicity na lang, is equal to 1 over CS, yung impedance, okay, times the current. Okay, so form to ng Ohm's law. Okay, voltage equals impedance times current. So parang V equals IZ, because Z is the impedance. Okay, so ngayon, let's solve this for I. Okay, solve natin for I. So this is I equals CS times V of C, VC. Okay, then ito, palit natin doon. Okay, palit natin siya doon. So basically, we will have, so pag pinalit natin siya, we will have B equals LS plus R plus 1 over CS times VC. Okay, so CS ito times VC. And then, solving for, ito ibabalik ko na yung of S. Okay, over V of S. Kasi ito tsaka to, function, parehong function yan of S. Okay, so bali, pag sinolve natin yung VC over V, okay, that should become 1 over, plus ito, distribute natin. So this becomes LC S square, okay, plus RC S plus 1. Okay, so ito yung transfer function na hinahanap natin. Pero, customarily, kapag meron tayong rational na transfer function, okay, we would want the leading coefficient. Gusto natin na itong leading coefficient na to is 1. Okay, kung it is convenient for us to have this leading coefficient equal to 1. Gawin natin. Okay? So, in this case, madali lang naman siya by dividing everything with LC. So, pag dinivide ko yan with LC, okay, that transfer function becomes, okay, pag dinivide natin yung with LC, that transfer function becomes, okay, so gawin natin siyang G of S. Okay, that transfer function becomes, kasi di-divide ko itong denominator niya by LC, i-divide ko rin yung numerator niya by LC. So, that becomes 1 over LC divided by S square plus R over L times S plus 1 over LC. Okay, so ito yung magiging transfer function natin. Okay, so ayun, ito siya. Okay, so if we want to put it in a block diagram, ito, pwede natin siyang ilagay dito. Okay, so that's how we obtain yung transfer function ng passive network niyo, ng series circuit na katulad nito. Okay, and sabi ko nga earlier, it is possible na pwede niyo rin itong gamitan ng voltage divider. So I will leave that to you as an exercise para so pwede niyo makuha ito using the voltage divider method. Okay, so ayan. So dito sa example 2.6, we now deal with a with a two loop network. Okay, dalawa na yung loops niya. Ito kasi isang loop lang ito. So ito, dalawang loops. Okay. So in cases like this, okay, pwede niyo itong gamitan ng mesh analysis. Okay, pwede niyo rin gamitan ng nodal analysis. Okay, yun nga lang kapag nag-mesh analysis kayo, ang makukuha natin is in terms ng currents. Kasi ang mesh analysis na kinukuha natin using the KVL. And kapag nagki-KVL tayo, yung ating resulting equations result in currents. Okay? So, pag naman nodal analysis, nagre-result yan sa voltages. Okay? So, say for example, we will try to find yung transfer function I2 over Vs using mesh analysis. We will have the following. So let's have the following. So sa first loop, okay, sa loop na to, okay, in this loop, we will have the following. So we have, ididiretso ko nitong Laplace transform. So basically, lagay nga muna natin. So basically, this is B of S. Laplace transform. B of S. Okay. Ito R1. Okay. Ito LS. Okay. So basically, ito I1 of S ito. I1S. Okay. Ito R2. So 1 over CS. Okay. Tapos ito I2S. Okay. So, kung gagawa natin siya ng mesh analysis, ganito ang mangyari dyan. So, we will have V, instead na VS, lalagay ko ng V. So, V, okay, minus R1 times I1. Instead na I1S, I1 na lang muna lalagay ko. Okay. Minus LS times I1. Okay. Plus LS times I2. Okay. Take note na sa mesh analysis, kapag dalawang currents yung dumaan sa isang component mo, okay, And since magiging opposite yung pagdaan niya, so yung isa doon negative, yung isa positive. Okay? So, yung I1, since ito yung kino-consider natin loop, at pa-negative tayo dito. Okay, kasi usually, mag-assign, kung matandaan nyo, mag-assign kayo ng positive dyan, negative dito. Okay, so yung I1 nyo, pa-negative. Okay, yung I2 nyo ngayon, since pa ganun siya, pag papunta siya dito, pag dumaan siya sa LS, positive siya. Okay, kaya magiging positive to. Okay, so V minus I1 minus LSI1 plus LSI2 equals 0. Okay, so that's the first loop. Okay, so ayan. So sa second loop, so tanggalin mo natin ito kasi magbabago tayo ng assumptions dito. So sa second loop, kung magsisimula tayo dito, okay, at pag ito yung ikot ng loop natin, so magiging plus naman ngayon to at saka minus dito with respect to sa I2. Okay, kasi yung I2 natin usually pupunta sa papunta yun ng mababang potential. Okay, so since pag ito yung assumption natin ng ikot ng I2, so magiging negative itong taas. Okay, so what happens is, kung sisimula tayo dito, we will be able to write yung ating mesh as 0. Okay, kasi 0 yung potential dito. Go set it dito as 0 potential. So minus R2 I2. Okay, minus 1 over CS times I2. Okay, minus LS I2. Okay, kaya lang yung ating I1. Okay, since paganda yung ikot niya, magiging plus ngayon siya. So plus LS I1 equals 0. Okay, so you have the following. Now, ganito gagawin natin dyan. Igugrupo natin yung mga I1 at saka yung mga I2. Okay, tapos yung V, nilipat natin sa kabila. Okay, pero basically, ang lilipat talaga ito, papunta dito. Okay, tapos ito, pabalik na rin natin yung sign nito. Okay, so, may purpose ako mamaya kasi, i-generalize natin ito, yung mesh analysis, para next time, hindi na tayo magsisimula sa ganun, sa basic na mesh analysis. Okay, so what happens is ganito. We will have, ito, lipat natin dito. Okay, so we will have, R1 plus LS times I1. Okay, minus LS times I2 equals V. Okay, so take note since ginawa kong positive to, magiging negative to. Okay, tapos ito, mareretain yung sign niya kasi parang basically ito, okay, ito, nilipat ko sa kabilang side. Okay, so ayun. Now, ito, i-opposite ko lahat yung sign nito. Okay, parang ito, ilipat ko sa lahat. Parang itong lahat, ilipat ko sa kabila. Parang palit sila ng sign. Eh, since 0 naman to, so ganun. Magiging equal to 0 pa rin to. Pero what would happen is this. Ito magiging negative. So this becomes negative LS I1. Okay. Tapos plus to. Okay. Yung magiging, lahat ng mga may I2, magiging R2. Okay. Plus, R2 plus LS plus 1 over CS times I2 equals 0. Okay. So, ito yung gagamitin ko ngayong equation. Or ito yung parang gagamitin kong basis para ma-solve natin yung Pero tignan niyo yung pattern nito mabuti. Okay, tignan niyo yung pattern niya mabuti. Galing dito. Okay. So take note na again, this is I2 of S. Sorry, I1 pala yan. I1 of S. Okay. So, kung titignan niyo yung loop 1, this is loop 1. Okay. In which the current I1 is the main current. Okay, the main current. Yung mga impedances na dadaanan niya, okay, which is R1 tsaka LS. Okay. is ito. Okay. So, yung loop na dinadaanan ng I1, ng current I1 ninyo is basically R1 plus LS, yung sum ng impedances ng mga components na dinaanan ni I1. Tapos, minus, okay, ano yung LS? Yung LS is basically yung parehong dinaanan ng I1 tsaka ng I2. Or basically, yung common impedance between I1 and I2. Okay, tapos negative siya. Okay, take note the sign, negative siya. Equal yan dun sa EMF, okay, yung electromotive force or yung source, okay, na nasa I1. So, ito siya. Okay. So, ayan. So, again, yung R1 plus LS is the sum of impedances that is connected to I1 or the current in loop 1. Okay. So, minus LS is the sum of impedances that is common to I1 and I2. So, yung common na yun, multiply natin kay I2. Equal yan dun sa source, okay, that is connected to I1. So, ito yun. Now, can we say the same para dito sa second loop? Okay. So, sa second loop, I2 yung current. Okay, I2 yung current natin. Okay. So, ngayon, ano yung sum of impedances na connected kay I2? That would be R2. Okay, ito. Plus LS. Ito. Okay, plus 1 over CS. Ito. Okay. So, yun yung sum of impedances na connected kay I2. Minus, okay, yung common impedances or yung common impedance kay I1 at saka kay I2, which is LS nga. Okay. Plus or equals, okay, dun yung EMF or yung source na connected kay I2. Now, in this case, makikita natin na walang impedance or walang voltage source na connected kay I2. So, therefore, isi-zero natin ito. Okay? So, yung ano na yun, yung technique na yun, yun ang gagamitin natin laging shortcut. Okay? Para sa pagkuha ng mesh equations. Okay, sa mga multiple loop networks. Okay? So, ang summary nun ito. So, sum of impedances around mesh 1 times I1. So, I1 is the current at loop 1. Okay? Minus sum of impedances common to two meshes times I2. So, yung common kay I1 siya kay I2. Okay? Equals sum of applied voltages around mesh 1. So, yung source na nakadikit kay mesh 1. Okay? So, yung next loop natin, kung i-consider natin yung second loop, okay? This is the sum of impedances around mesh 2 times I2 minus the sum of common impedances common to I1 and I2, okay, times I1, okay, equals the sum of applied voltages around mesh 1, mesh 2, I mean. Okay, so yung yung equations na to or yung shortcut na to, pwede nyo i-apply yan sa 3-loop network and 4-loop network. Kahit ilang loops ba yan, basta ganun pa rin yung rule. Okay, so titingnan nyo lang isa-isa yung loops na kinoconsider nyo. Okay, so yun yung gagamitin natin parang pinaka-shortcut dito. Okay. So now that meron na tayong equations, okay, para sa network ninyo. And since dalawa yung hindi natin alam, I1 and I2. Okay. Basically, we can now solve for I2. Okay. Kaya lang kapag ganito, gagamitan natin siya ng methods ng determinants. Okay. So paano mag-work yung method ng determinant dito? Okay. Una, hanapin muna natin yung determinant ng matrix D. Okay. So, ano yung matrix D? So, basically, meron kayo ditong parang pinaka-main na matrix or yung coefficient matrix ninyo. Okay. In which, hanapin natin yung determinant niya. Yung coefficient matrix niyo ito. Yung coefficients ng I1 tsaka I2. Or yung coefficients ng unknown niyo. Okay. So, basically, this is R1 plus ls, ito. Tapos yung second row, first column element niya is negative ls. Okay. Then, negative ls yung first row, second column niya. And then, finally, yung second row, second column element niya is R2 plus LS plus 1 over CS. So, hanapin natin yung determinant na yan. Okay. So, in this case, since 2 by 2 determinant lang naman ito, pwede nyo gamitan ito ng basket method. Okay. So, simply, your T is basically R1 plus LS times R2 plus LS plus 1 over CS, okay, minus L square S square. Okay, that is your T. Okay, so ayan. Now, simplify natin ito. Okay, if we simplify this one, medyo mahaba-haba lang ito ng konti. So by expansion, makukuha natin yung D natin as this one. So, R1 plus R2 LCS square plus R1 R2 C plus L times S plus R1. Okay. So, ito yung details. Medyo makukuha nyo naman ito. Makukuha nyo naman yung copy nito. Okay. So, yan yung D natin. That's how we get the D. Okay. Yung D na yan, actually, yun yung magiging denominator ng ano nyo. Okay. So, kung matatandaan nyo sa Cramer's rule ninyo, okay, kung i-review nyo yung Cramer's rule niyo, yung D na yan is yung denominator coefficient niyo. Okay. Paano yung numerator? Okay. So, basically, yung I2 natin ngayon, okay, yung I2 natin ngayon is basically is di2 over D. Okay. So, yung D, ito yan. Okay. Paano yung di2? So, yung di2 is basically yung ating coefficient, itong coefficient matrix niyo. Pero yung column that represents I2, papalitan natin ng constants. Okay? Na galing dun sa ano niyo, sa equation niyo. Okay. So, una, take note na itong column na to represents yung I1. Kasi itong column na to represents I2. Okay. So, basically, ito yung, ang sinsolve natin is di2. So, ito yung papalitan natin, itong column na to. Ano yung papalit natin? Ito, yung V at saka yung 0. So, ito, papalitan natin ng V at saka 0 ito. Okay. So, basically, yung di2 natin is the determinant ng R1 plus LS plus negative LS, ito V, tapos 0. Okay. Then, solve natin to as a determinant. So, in this case, this becomes 0, okay, minus so this becomes so 0 minus ito. So since minus negative ito, so this becomes positive LS times V. Okay, so that's your BI2. Okay, so ayan. Now, balikan ko lang itong may nakalimutan pala ako dito. Okay, so ang nangyari pala dito is nag-LCD ako pala, nag-LCD kasi ako somewhere dito. Okay, so yung LCD ko, dapat sinulat ko pa. So, ang LCD nito is basically over CS. So, dapat meron akong over CS dito. So, that would be my D. Now, what happens is, i-divide ko ngayon para makuha ko si I2 ngayon. Okay, para makuha ko si I2 ngayon. Okay, para makuha si I2 ngayon, i-divide natin ito, si LS D divided by this thing. Okay, so this becomes medyo mahaba-haba to, no? Pero basically, lagay natin D na lang. Okay, lagay mo natin D. Okay, so LSD minus divided by D. Ngayon, ang kailangan kong kunin transfer function is basically I2 over D. Okay, kailangan kong kunin yung transfer function na I2 over V. Okay, so ito yung kailangan kong kunin transfer function. Okay, so in that case, kung I2 over V, then simply, divide ko lang siya dito. Okay, so we will have I2 of S over V of S equals, itong D ko kasi, merong denominator dito. Okay, so since denominator siya ng denominator, okay, basically, pwede ko siyang ilagay doon sa numerator. Okay, so lalabas ngayon dyan is, mamumultiply siya dito sa LS. So this is LS times CS. So that becomes LC S squared. Okay, so that becomes LCS squared. Okay, that becomes LCS squared. Divided by, itong denominator na to. This entire denominator. Okay, so which is, sulat natin siya as R1 plus R2 times LCS squared plus R1 R2C plus L times S plus R1. Okay, so ito ngayon yung magiging transfer function natin. Okay, now sabi ko nga, if it is convenient, okay, sana gawin natin itong yung leading coefficient ng denominator nyo, sana 1 if it is convenient. Okay, pero in this case, mukhang hindi siya magiging convenient, so let us leave this to be. Okay, so pwede natin siya, siguro pwede natin iwan muna ito as ano, pero sa mga susunod na practice natin, itong coefficient na to, as much as possible, okay, yung leading coefficient nito, iiwan na natin or gagawin natin 1. Okay, so that gives you your transfer function na ito. Okay, so ayan. Ayan. Okay, now what if nodal naman? Okay, we are asked to find yung transfer function na to using nodal. Okay, sisimulan lang natin siya. Okay, sisimulan ko lang muna siya. And then, I'll leave it to you kung paano makukuha yung VC over V. Okay. So, basically, kailangan naka-Laplace transform din ito. Okay, so let's have this as LS. So, gawin natin LS ito. Kasi ito 1 over CS. Okay, still this is VS. Okay. Tapos mag-assign tayo dito ng isang node dito. So, which is, we'll call this VL. Itong node na to. So, VL of S yan. Tapos, this is VC of S. Okay. Now, basically, ang nodal analysis, naka-base yan sa, KCL or Kirchhoff's current law. Okay. So, una, tingnan muna natin, we will notice na yung sa node na to, sa node na VL, yung current na papasok dyan, say I1. Halimbawa lang I1 muna. Okay. I-ignore ko na tong loop na to, hindi nakasali. Okay. Is equal dito. Equals dito. Sabi natin IL ito. Okay. Tapos, plus ito. So, sabi natin ito ay I2. Okay. So, using the nodes, makakapag-establish ako ng equations para sa I1, IL, tsaka I2, or expressions para sa I1, IL, tsaka I2. Okay. Pero basically, sisimulan ko yan sa notion na ang I1 is basically IL plus I2. Okay. So, kung nodal ito, yung current na to is basically yung potential difference divided by the impedance. So, yung potential difference, tinutukoy natin is yung difference ng voltage dun sa dalawang dulo ng impedance mo. So, dito, ang impedance ko, R1. So, yung nodes sa dalawang dulo niya is VS at saka VL. Or V of S at saka VL of S. Okay, so yung I1 ngayon is basically i-ignore ko muna yung of S. Okay. Minus VL divided by R1. Yan yung I1 natin. Okay. So, equal yan sa IL. So, yung IL natin, since ito siya, so, yung impedance na dadaanan nun is LS. Okay, tapos yung voltages dun sa nodes niya is basically VL at saka 0. Kung ito yung ground natin. Okay, so basically, IL is basically VL divided by LS. Okay, and then, plus, yung I2 natin is basically ito. So, yung dadaan dyan, which is, yung dadaanan ng I2 natin is basically R2. So, yung R2, we have the voltage, we have the nodes VL at saka VC. Okay, so you would have VL minus VC divided by R2. That is your I2. Okay. So, yun yung isang node na, yun yung isang natin, yung isang KCL natin dun sa node VL. Okay. Yung next node natin is itong VC. So, ito yung first node, ito yung second node natin. So, basically, yung dadaan na current dito sa, yung papasok na current dyan sa VC, yun din yung lalabas kasi wala naman ng branch yan. Hindi naman na magba-branch dito yan. So, yung papasok dyan, basically lalabas din. Okay. So, basically, we will have I2 equal sa current dito. Or I2 equals I2. Okay. And, yung I2 na dadaan sa R2 ninyo is basically VL minus VC divided by R2. Okay. Equal yan sa DC over 1 over CS. Okay. So, yan yung yan yung nodal equations natin para sa second node nyo na DC. Okay. What we will do is we will rearrange these equations. Okay. Para magkaroon kayo ng equation in terms ng VL at saka VC. Okay. So, i-rearrange natin siya ha. Okay. So, sa pag-rearrange sa kanya, ito gagawin natin. Okay. So, una, itong first equation natin. Okay. Ang gagawin natin is itong si VL, ililipat natin dito. Okay. Tandaan nyo, pwede kong paghiwalayin to as V over R1 minus VL over R1. Tapos yung negative VL over R1, ililipat ko dito sa kabilang side. Okay. Tapos, itong VL over R2, isasama ko dun. Kasi yung lahat ng yun, may numerator na VL. Okay. So, ang lalabas ngayon doon is ito. Yung dito sa left side muna, sa right side, gagawin kong left side ngayon. That becomes 1 over R1 plus 1 over R2 plus 1 over LS times VL. Okay. So, hopefully malinaw yan kung saan ko nakuha yan. Okay. So, minus ngayon ng 1 over R2 times BC equal ito, yung V of 1 over R1 times V. Yan. So, that is your first equation. Yung second equation nyo, bali, ang mangyayari is ito, lipat natin dito sa kabilang side. Okay. Tapos, kunin na natin yung magiging VL. Kasi yung VL natin is negative 1 over R2 times VL. Okay. Plus, okay, 1 over R2. Okay. Plus, ito kasi, naka-complex fraction to. Itong 1 over CS, pwede kong i-angat ito. Taas. So, magiging CS ito bale. Okay. Times BC. Tapos, equal yan sa, since ito, nilipat ko lahat dito, magiging 0 tong left side niya. So, ito yung naiwan. So, this would be your two equations in terms of VL at saka BC. Now, ang pwede nyo gawin dito is, para hindi siya masyadong komplikado is, yung reciprocal ng resistances, katulad itong 1 over R1 at 1 over R2, gawin nyo munang conductance. So, alam natin from basic electricity na for basic electric circuits natin na ang conductance ninyo is basically 1 over R. Okay. So, yung conductance na quantity is 1 over R. Pero ito, hindi nyo pwedeng gawing conductance kasi complex number ito. Okay, so this is not simply obtained by getting yung tawag na admittance. Okay, kasi yung admittance nyo, meron dalawang parte rin yan. Conductance plus susceptance. Okay. So, kung maalala nyo yan sa electric circuits to ninyo. Okay. Pero pwede nyo gawin dito. Pwede nyo gawin tong G1 plus G2 plus LS. Okay. Minus G2 times VC equals G1 V plus negative G2 VL plus G2 plus CS times V equals 0. Okay. And then from there, pwede nyo nang isolve yung VC over V using determinants. Okay. So, I will leave this to you as an exercise para mas ma-practice nyo to. Okay. Pero, in most cases, pwede naman nating i-generalize yung ating mesh analysis na approach. Okay. Ang nakita nyo nga lang dito kanina, ang na-solve ko is I2. What if gusto kong i-solve yung VC over V? Okay, galing dito. Okay. Kung gusto kong i-solve yung VC over V, galing dyan. Okay. Tandaan nyo lang na ang dadaan na current dito, ang dadaan na current dyan ay, ang dadaan na current kasi ang variable of interest niyo is itong VC. Okay. So, tandaan lang natin na ang current na dadaan dyan ay yung I2. Okay. So, basically, pwede nating i-state dyan na pwede natin i-account dyan na BC equals yung impedance doon 1 over CS times I2. Then solve natin to for I2. So this is I2 equals CS times BC. Ngayon, itong CS times BC na to, itong CS times BC na yan, ang ipapalit natin dun sa I2 na to. Okay, yan yung ipapalit natin dun sa I2 na yan. And then, kapag naipalit na natin siya, okay, we will be able to replace, or we will now be able to solve yung VC from there. Okay, so, ayun. So, basically, ang gagawin natin is, titingnan natin kung, ang isosolve natin, we will start with the mesh analysis. Tapos, ang isosolve natin current is kung ano yung dadaan dun sa component of interest natin. Kung voltage yung hinahanap natin from there. Okay? So, since in this case, halimbawa, hinahanap natin yung voltage dito or yung VC dito. Okay? Hanap natin yung current na dumadaan dyan. Kung ito naman yung hinahanapan natin, say ang hinahanap nyo is VR2. Okay? Titingnan nyo kung ano yung current na dumadaan dyan, which is basically I2. So, I2 pa rin yung isosolve nyo. Okay? So, ganoon din dito. Kaya lang dito kasi, ang dumadaan, I1 tsaka I2. So, i-minus nyo pa yun. So, that's I1 minus I2 pa. Okay? So, para makuha yung VL of VLS, that's I1 minus I2 times LS. So, susolve nyo pareho yung I1 tsaka yung I2. Okay? So, ayun. So, proceeding now, okay, with example 2.7. So, let us write button and solve the mesh equations for this network. Okay, so hindi naman tayo kailangan mag-solve dito. Pero by visually solving this one, okay, makikita natin na makukuha natin itong equation to. For example, sa loop na to, we have 2s, okay, 2s plus 1 plus 1. So, 2s plus 2 times I1 minus yung common sa I1 tsaka I2, which is 2s plus 1. Okay. Minus I3, which is yung common sa I1 at saka I3. So, bali 1. So, negative. So, negative din to. Okay. Equals yung voltage na nakadikit sa I1. So, that's your first equation. Yung second equation nyo is yung impedance dun sa I2, which is 4s plus 2s. So, 4s plus 2s plus 3s. So, that's 9s plus 1. So, 9s plus 1. Okay. Minus yung common kay I1 saka I2, which is 2s plus 1. Okay. Tapos yung common kay I2 at saka I3, which is 4s, which is 4s. So, that's negative 4s times I3. So, wala naka-impress na voltage sa loop na to. So, magiging 0 yung right side natin. Okay. Para kay I3 naman, yung total impedance dito is 4s plus 1 plus 1 over s. So, ito yun. Minus yung common sa I1 tsaka I3. Okay, which is 1. Tapos yung common kay I3 at saka kay I2, which is 4s. Which is 4s. So, ito yun. So, again, wala naka-impress na voltage kay I3. Okay, so therefore, 0 yung right side natin. Okay. So, that's how fast we can obtain yung equations, yung mesh equations ng electrical networks natin, kahit ilang loops pa yan. Basta gamitin lang natin tong technique na to. Okay. So, ayun. Now, finally, let's have this. Okay. Let's have this one. So, tingnan natin to. Okay. So, let us write but don't solve the mesh equations for the network shown. Okay. So, here, meron tayong three loop network. Okay. So, meron tayong I1, I2, at saka I3. Okay. So, sa I1, okay. Again, yung total impedance sa I1, which is 2s plus 2. Okay. So, we have 2s plus 2. Tapos yung common kay I1 tsaka I2, which is ito. So, we have 2s plus 1. Negative. Okay. Tapos, again, yung common kay I1 tsaka I3, which is ito. So, 1 tapos negative. Equal, sa right side natin is yung naka-impress na voltage kay I1. Ito. So, which is itong Vs. Okay. So, next. Kay I2, yung naka-impress, yung total impedance sa kanya is 4s plus 3s plus 2s, which is 9s plus 1. So, ito. Okay. Minus yung common kay I1 tsaka kay I2. So, ito siya. So, 2s plus 1. Tapos yung common kay I2 tsaka I3, which is ito. So, you have 4s tapos negative. Okay. Equal siya sa naka-impress na voltage kay loop I2, which is wala naman. So, 0. Okay. And then, finally, yung kay I3, sa loop I3, yung total impedance is 4s plus 1 plus 1 over s. Okay. So, yun. 4s plus 1 plus 1 over s times I3. Okay. Minus yung common kay I1 tsaka kay I3, which is ito. So, negative I1. Okay. Tapos, yung common kay I3 at saka I2, which is 4s. So, ito. Okay. So, pansinin nyo lang din na kapag nakapuo kayo ng 3 equations, 3 unknowns, this is a symmetrical, yung itong right side. Okay. Ay, yung left side pala. Okay. Is a symmetrical matrix. Okay. So, mapapansin nyo, ito tsaka to, pareho. Kasi ito yung common kay I1 tsaka I3. Ito naman yung common kay I3 tsaka I1. So, pareho lang naman yun. Tapos, mapapansin nyo na ito at saka to, common. Kasi ito yung common kay I2 at I3. Ito naman yung common kay I3 at I2. So, pareho to. Same thing, ito pareho din to. Okay. So, ito yung common kay I2 at I1. Ito rin yung common kay I1 tsaka I2. So, pag ito, ginawa nyo matrix at transpose nyo, pareho yung lalabas. Okay. At least yung coefficient matrix niya. Okay. So, pagpapareho natin yun. Okay. So, and then, finally, we have the following. Let's find the transfer function VLS over V for this circuit. Okay, so 3-loop network ulit ito. Okay, so kunin mo natin yung mesh equations. Okay, so we have, okay, sa first loop, ito, Ito yung first loop natin. Let's consider this to be your first loop. So that's I1. Okay. So ito yung I2 natin. Okay. Ito yung I2. And then finally, ito yung I3. So, establish natin yung um, mesh equations ninyo. For loop 1, we have um, S plus 1, okay, times I1, okay, minus yung common kay I1 tsaka I2 which is S, okay, times I2, okay, minus yung common kay I1 at I3 which is 1 times I3. Then, yung equal niya sa impress voltage kay sa loop 1 which is Vs. So, times V. Okay. So, that's for loop 1. For loop 2, so, ito yan, yung common kay I1 tsaka I2. So, this is negative S I2, I1, I mean, plus yung sum of impedances dun sa I2, which is 2S plus 1. So, 2S plus 1 times I2. Okay. Minus yung common kay I2 at I3, which is 1 din times I3. So, yung impressed voltage kay sa loop 2 is 0. Na yung common, yung sa I3 natin, okay, sa third loop natin, we have negative 1, negative I1, okay, so, yung common kay I1 at I3, so, bali ito yun, negative, bali 1, okay, so, I1, minus yung common kay loop 2, kay I2 at saka kay I3, which is again 1, so, minus I2, okay, and then yung sum of impedances sa loop 3. So this is 2s, so plus 2s, plus s plus 2 times I3 equal 0 yung impressed voltage sa loop 3. Okay. Okay, so from there, let us solve for, since ang isa-solve natin is yung VL. Okay, yung isa-solve natin is yung VL. Take note na ang dumadaang current dyan is I2. So, ang isa-solve natin dito sa mesh equations natin is yung I2. Okay, so first, let us find yung D. Okay, or basically, pwede natin i-diretso ito as I2. Okay, equals, so sa baba, yung determinant ng matrix coefficient nyo, which is in this case, S plus 1, negative S, negative 1, okay, next is negative S, 2S plus 1, negative 1, then negative 1, negative 1, S plus 2. Okay, sa taas naman, same thing, pero ang papalitan natin yung I2, ito, ng V00. So this is S plus 1, negative S, negative 1, V00, tapos negative 1, negative 1, S plus 2. Okay. So, ayan. So, attempt natin i-solve yan. Now, since 3 by 3 ito, okay, 3 by 3 ito, pwede nyo pa rin itong gamitin ng basket method kasi 3 by 3 ito eh. So, ang hindi pwede nang gamitin ng basket method is yung 4 by 4 pataas. Kasi pagdating doon, kailangan nyo ng mag-expansion by minors. Okay, pero in this case, pwede pa ito gamitin na ng basket method. So, solve lang natin siya. Okay. So, after natin ma-apply yung basket method, okay, so, magiging ganito siya. Okay, so, mamaya mas makikita niyo yun in detail. And then, finally, ito yung magiging resulta nung I2. So, yung I2 natin is basically this one. Okay, now, what I want to do now is to replace I2 with an expression for VL. Okay. Now, in this case, take note natin na ang VL natin, okay, is basically, okay, ang VL natin is basically yung impedance L, S, or in that case, 1. Okay. So, in that case, 1 siya. So, it's 1 times S, okay, times I2, yung current. So, voltage equals impedance times current. Okay. So, therefore, from there, we will have I2 equals VL over S. So, ito ngayon, papalit natin dito. Okay. So, papalit natin siya ngayon din. Okay. We will have VL over S equals V times S square plus 2S plus 1 divided by S times S square plus 5S plus 2. Okay. And then, itong S na to, magka-cancel to. And then, we solve this for, ito, divide natin dito. So, we can now have our G of S, which is VL of S divided by V of S. Balikan natin yung of S ng dalawang functions natin, which is now S square plus 2S plus 1 divided by S square plus 5S plus 2. Okay. So, ito yung transfer function na hinahanap natin. Okay. So, ito yun. Ayan. Okay. So, nakuha natin itong ating transfer function dito. Now, just to end this discussion. It is possible na itong mga equations nito, okay, can actually be solved using yung tinatawag na symbolic package ng octave, or in terms ng MATLAB, kung MATLAB yung pag-uusapan natin, yung symbolic math toolbox ng MATLAB. Okay, pero since octave yung ginagamit natin ngayon, we can be able to use yung tinatawag na symbolic package. Okay, package kasi yung tawag ng octave sa mga extensions nila. Okay. So in a separate discussion siguro, I will demonstrate kung paano i-activate yung symbolic package sa sa octave niyo. Okay. Pero in this case muna, pakita ko muna kung paano to i-solve using paano natin i-solve itong problem na to using octave. Okay. So, ayun. Again, masosolve nyo lang to kapag naka-activate or naka-install na yung symbolic package ng octave niyo. Okay. So, ganito. First, magde-define tayo ng matrix A. Okay. So, yung matrix A na yan is basically ito. Okay. Pero bago yan, kailangan nyo munang i-define as a symbolic variable yung S. At saka later on, yung V. Kasi kailangan natin yung V as a Okay. So, i-define na natin yung S at saka yung V as symbolic variable. So, we do that by typing na command sims S. Okay. Yung symbolic variable natin tsaka V. Okay. So, ayun. Wait lang. Clear muna natin ulit para wala tayong variable dito. Okay. So, we have sims S at saka V. Okay. Then, yun. Define natin itong matrix na to. So, we will have A equals. So, mag-define tayo ng matrix sa octave. Okay. So, yung row is separated by comma, column is separated, yung columns are separated by comma, rows are separated by semicolon. Okay. So, we have S plus 1. Okay. And then, negative S. Then, negative 1. Next row, we have negative S. 2 times S plus 1. Okay. And then, negative 1. And then, negative 1. Negative 1. And S plus 2. Okay. So, yan. So, hindi ko lalagyan ng semicolon to para makita yun yung symbolic matrix natin in relay tree. So, ito siya. Ito yun. Okay. Now, let's define now another matrix B. Okay. Another matrix B in which ito yung column matrix nitong right side nung ano niyo, nung equation niyo. Okay. Also basically ito. Okay. Pero hindi ito matrix to. Yung ito lang, yung column lang to. Yung column matrix lang to. So basically that's B 0 and then 0. Take note column matrix to. So um, separate rows itong B0 at saka 0. So, isang row, second row, third row. So, kaya separated siya ng semicolon kasi gumagawa ako ng panibagong row. Okay, so ganito yung itsura nun. Yan. Now, bigyan na solve for I. Okay, so directly, pwede natin i-solve yung I nito by using the left division. A left divide B. Okay, so makukuha natin yung I as A left divide B. Ang magiging sagot nito is a 3 by 1 matrix din, corresponding to I1, I2, and I3. Okay? So, kasi ito yung row na nagre-represent ng I1, ito yung row na nagre-represent para sa I2, ito yung row na nagre-represent para sa I3. Okay? So, ang makukuha natin dito is yung I1, I2, at saka yung I3. Okay? So, pag press natin yung enter, we will have the following. Okay? So, itong unang to is your I1. Okay? Ito yung magiging I2 nito. So, ito yung magiging I3. Okay. So, take note na yung I2 ninyo, ito. Okay. Itong I2 ninyo is basically V times S square plus 2S plus 1 divided by S square plus S square divided by S times S square plus 5S plus 2. Ito yung nakuha natin. Nakuha natin to. That is your I2 pala. I2. Okay. So, from there, kukunin na lang natin siya. Tapos, itutuloy na natin siya dito. Okay. So that's how we solve this problem using Octave. Okay. So there.